Hey guys, Abel here. Today I'm going to be discussing how to compile your own kernel on Linux. So the first thing I'm going to do is I'm going to show you how to know what kernel you're using. So if you type in uname, so that uname tells you about the kernel that you're using. So uname minus A will give you a lot of different information. If you want to specifically the kernel version, you do uname minus R. So since I'm using Manjaro, the default kernel here is 5.6.15, or at least on this version that I have. If I reboot, I think I'm on 5.6.19. Install the kernel. You're going to need sudo privileges, but you don't want to use them the whole time. So you're going to want to have a user on the system, and you're going to be doing it as the user for the most part, unless you're installing the kernel. When you're compiling it, you don't want to do it as root. That's the first thing. So now let's go find the kernel, www.kernel.org. And we will copy the location of the tarball. Now let's download that tarball. Okay, so now that I got the source installed, we're going to make a directory called source. Go into that directory, and if you notice, the file that we downloaded has the extension of tar-gz, so it's a zipped or compressed file, and it's also what's called a tarball or a tape archive, which basically takes a whole bunch of files and it writes them into a single file that you were able to, historically they were written on tapes, and now it's just a convenient way of making a bunch of files into one file. So we want to extract that and verbose it so that way we can see what we're doing, and the file is, if we go back one directory, and that we want to extract it locally right here. Okay, and now, okay, so now when your kernel's running, right, so like I said earlier, you have this kernel running. Now, the kernel that's running actually has a config file to it. A good way, if you know that this kernel works, it is a good way to just copy that running config file into here and use that to compile your kernel. So the way you would do that, if you look in ls dash, if you look in proc, right, you have a bunch of things here. Most of these here, these are all processes, and then you have a bunch of other random stuff here. So if you look carefully, you'll see that you have, where is it? Config.gz. That is, again, gz means that it's zipped or compressed. So we're going to want to, so that is the kernel config. So zcat, so zcat is basically the same thing as cat, which just reads the file, and it's used for, but zcat is used for compressed files. And we're going to read it, and we're going to send the output to .config. So now we took the running kernel's output, the running kernel's config file, and we use it here as a local config. Now you have a couple options right now. So we're going to want to edit this config. So to start, we're going to use the simpler one, which is make xconfig. And that'll give us a nice GUI. If I know how to type. Nope, I spelled that wrong. I still spelled it wrong. That's better. Okay, so over here in the GUI, here's where you're able to change things, right? So we're going to go to General Setup, and we're going to change the local version. Alright, so let's call it AWOL, because that's mine. I'm going to save the changes. File, quit. So now that it's saved. Now, there's an older way to do this, and this is also a good way to do it when you don't have a graphical interface running, because xconfig, as you can see from the X, it requires that you have a graphical interface running. So we're going to try this one. Make menu config. This is the one that I'm more familiar with. And this one will open up what's called a TUI, or a terminal user interface. So if we go to general setup, I don't know why that didn't save, but let's change that to, well, okay. And let's save the changes, exit. Now here again, you could change a bunch of different things. I know I kind of glossed over that, but I'm not very good at, I'm not very familiar with Xconfig. I just want to show you that it's out there. And so now that we did all the changes that we need to make for now, generally speaking, you would want to make some more changes, but there's no need. We're going to, one other thing I wanted to mention. Okay, so if you look here, when you press make menu config, right, let's go into, let's say, file systems. Okay, so you have a bunch of different types. So let's look at, let's say, RiserFS. So if you notice there's an M next to it and not a star. If I press space again, it'll have a star. So what does that mean? What M means is that it's a kernel module. So let's show you a bit of kernel modules. LSMod. So let's look at the kernel modules that we have. Right, so if you look here, you might notice that there's one called, where was it? It's called, let's say, PS mouse. Let's see where PS mouse is not in use. So we could actually safely remove PS mouse from the kernel. Now, oops, let's remove PS mouse from the computer. As sudo, obviously, because you need to be root to touch the kernel. Now lsmod. Now let's look at what we have installed. Now if you notice, PS mouse is no longer there. So if we were to be using a PS2 mouse, it will not be working anymore. Now let's put PS mouse back into the kernel. And if we type in lsmod, we see that it is currently running. So now if we're using a PS mouse, we'd be able to use it. Now this is one type of thing. Now I want to discuss a little bit about user space backwards compatibility versus kernel backwards compatibility, or kernel space or internal kernel, whatever you want to call it. When you make a program, a binary program or an open source program, right? So you have the source code and the binaries, and you take that and it works against one version of the kernel. Chances are it'll work on another version of the kernel, assuming that it doesn't have to act with the internal kernel API or ABIs, right? An API is an automated programming interface, and an ABI is an automated binary interface. Now here's the important part. If that program interacts with the internals of the kernel, there is no guaranteed backwards compatibility. So a good example of this is your NVIDIA driver. If you have an NVIDIA driver, that driver will not be backwards compatible between one version of the kernel to the next. Instead, you'll need to compile a new version of it with each version of the kernel. So now let's go compile our kernel. Okay, so now to compile our kernel, all we do is we type make -j, and j is how many jobs you have. Now, another little note about how many jobs you have. There's a common misconception that the higher you do, the better, or the many threads your system has, and you do however many threads you have. That's inaccurate. What you actually want to do is you want to do how many physical cores your system has. Right, I'm in a VM, so that's really irrelevant. I forgot. The other thing you want to do is you actually want to do one more, and I'll show you the reason why here. So let's open up a new terminal while this is running. Alright, so this is going to be running in the background. And let's use top. Right, so top shows you how many programs are running in your system at a time. Here's all the compiling. So 1, 2, 3, 4, 5, 6, 7. So right now it's running 7. Right now it's running even less. So what you might notice is that it's not using all the cores that you assigned to it. And the reason for that is because when you assign cores, you're actually just assigning jobs. And you're telling it you could use X amount of jobs. So if I tell it could use 8 jobs, it's only going to use 8 jobs as the maximum. But most of the time, it's not actually going to hit 8. So therefore, you actually want to assign it a lower number of jobs. So this is going to take a couple minutes. I'll come back to you when this is done. One other interesting thing, if you have to stop the compilation for any reason, and you go back into it, it does something in the beginning. Let's pause that for a moment. Called check. And what check basically does, I think it's check, is it checks to see how much of the compilation you already did, and it'll actually just continue from where you left off most of the time, or close to where you left off. So it's not a big deal if you have to stop the compilation in middle and get back to it. Okay, so now that that's done, we're going to need to install the kernel. So the first thing we're going to want to do is we want to install the modules. Oh, and before I forget, we're going to need sudo here. So this time you're going to want to do sudo, because if you don't do sudo, you're writing the files to a sudo protected directory, which is libmodules. So here, when you're installing the modules, you're going to need sudo, and also when you're installing the kernel, and I spelled it wrong. So here, if you look right, all these here, so it's writing this file into libmodules, and then it's the kernel name, and if you want, we'll check it after. And let me just speed it up, because I forgot. Now that should go a bit faster. Okay, so now that that's done installing, there's two choices. One of them is we could do sudo make install, right? Or you could actually go and do everything here manually. I'm going to do sudo make install. Okay, so now if you get this error here, can't find Lilo, and you don't have Lilo installed, which is most probable, especially if you're using Manjaro, because you're using grub. Lilo is just a bootloader. It's fine, it doesn't matter. If you're wondering, your kernel is located in this folder over here. Right, sorry, no, it's not that BC image, that is your kernel. System map, don't really worry about it unless you're going to be doing kernel debugging. Now, if we go to cd boot and ls, okay, so now you'll see that you have system.map, which is good for debugging, and vmz Linux. Now, we can't just continue like this, but I actually prefer to rename the kernel based on the version. So, mv, so let's move vmz into, no, I should know how to type. Okay, so let's name it similar to the other one, 5.8 x, no, 5.8 star x86 underscore 64. So now, and sudo obviously. So now it has the same name as the other one. So if we do ls minus l, right? So you have kernel 5.6 and 5.8. So now we're going to want to make a kernel image, right? So making it to right dash k. So let's make kernel version is. Oh, so before I forget, we're going to forget what the name of the kernel version is. So ls minus dash lib modules. Okay, so if we look here, this is the kernel version, right? So 5. So we see here, and in each one of these is different modules, and that's where modules are kept. So now we're going to build a kernel image, dash k and dash g. So what are we going to name? We're going to name it init ramfs 5. Oh no, okay, let's just do it like this. Dot image, perfect. And the b is meant to be 8. Okay. And obviously you're going to need sudo for this. Perfect. So now if we do ls minus l, we have a kernel image. And now all we got to do is we got to tell grub about it. Alright, minus o. So grub make config tells grub to make a config file. Minus o tells it what the output file is. If you're on Ubuntu, you should just have an update grub command. But I'm not on Ubuntu, so I don't have that. And also Ubuntu handles this whole thing differently. I don't know how to do it on Ubuntu. Boot. And the normal grub location is boot grub config. I think Fedora has it in the EFI directory, but then again, I'm not sure. And obviously it has to be run as root. Okay, so now if you look here, right, this is what we want to see. We want to see, we found this one, right? So this is our new kernel, and it found the initrd image. You sometimes can boot without an initrd, but I'm not interested in dealing with that right now. Now, one thing I want to point out, let's say we did not rename it, right? So for simplicity's sake, touch vn linux, no linux, right? Sudo. Okay, so now, right, now theoretically, if there's a kernel image here, right, it should find vm linux. So let's do that again. But if you notice, it did not find it. Why not? So the reason is because you have a file that tells it where to look. So let's go to that file. It's etc grub.d and then 10 Linux. So now here, this is the script that it uses to search for Linux kernels, and it goes by file name. But you'll notice something interesting, and I think this is specific to Manjaro. Wait, I missed it. Okay, so if you look here, for in boot VM Linux, right, or boot kernel, if you notice, there's this little thing here, which means that you are required to put a kernel version. I'm going to just remove all of these dashes here. Alright, so now it does not require a kernel version after it. If it has one, it'll still read it, but it is not required. And the other thing we need to change, we wanted to look for init.ramfs.image. Okay. No, this isn't, crap. Yeah, so if you note here, grub requires you to have a version. So now let's remove that file. Let's do it as root. Okay. So now we made an initRD image and we updated grub. So now we should just be able to reboot. And one other thing, I want to be able to see the grub menu. So now here, the way grub works, use nano, trying to, right? So we don't want grub to be hidden. We want to be able to see it. So grub basically reads from this file, and okay, so grub reads from this file and sets its config based off of that. So now we're gonna have it make another config, and now it should be visible when we read it. So now we're gonna reboot to the new config. Let's try it. Escape for boot menu 2. Okay, so now if we click advanced options, we have our new kernel 5.8 x86-64. And let's try to boot to it. And there we go. We're up and running. Terminal emulator. And let's check our kernel version. And there we go. We got our kernel version running. Now I just want to discuss a little bit about DKMS and how to use it better. It's a side note. But let's say we decided we wanted this kernel to have a DKMS driver. So we're going to use the OpenRazor driver for this. And let's open up a terminal emulator. Okay. So this is an AUR package, so I'm going to install it quickly. I'm going to go over how to install them in other videos. This is just for demonstration purposes. Okay, so now if we look here, okay, if you look here, right, so it's doing DKMS install. So since it's a kernel driver, can install. So let's say we were to type in dkms. Let's remove it. Let's just reopen our shell. Oops. Okay, so let's uninstall this from the kernel. Okay, so now we're going to go and install this. So if you look right now, it's simply compiling the driver for our kernel. And every time we update our kernel, all we have to do is run this command, and it'll just compile the driver for our kernel. So that's what dkms does. You can use this for NVIDIA. I think ZFS has a good module for it. I didn't want to demonstrate this with ZFS because ZFS doesn't really work on the new kernels. Alright, I think that's all.